This question is saying use L'Hopital's, and we get this limit. So if we put in zero right now, put in a zero here and a zero here and a zero here, what are we going to get? It's always good just to start with that. Well, that would be 11 times 0 times the sine of 0 over 9 minus 9. What's the cosine of 0? It's 1. So notice that's 0 over 0. And 0 over 0, that's when we can use L'Hopital's rule, right? You good on that? L'Hopital's rule says that when you have 0 over 0 or infinity over infinity, then you can take the derivative of the top and the bottom separately. Whoops, skipped my E there. Separately. So not a quotient rule, but top and bottom separately. So let's do it. I'm going to use L'Hopital's. I'm going to use L'Hopital's rule. So we say equals. We usually put an H above it to indicate we're using L'Hopital's rule. Limit x goes to 0. Okay. Now, top and bottom separately. Separate derivatives. So let's do the top. How do we do the derivative of just the top? Let me erase all the junk that's there. In fact, let me just make the cut. So right there. How do we do the derivative of the top? Product rule. You see that? Because it's two functions of x multiplied. We got 11x and we got sine x. So they take turns. So the derivative of 11x first is just 11 times the second function unchanged plus the first function unchanged, not his term, times the derivative of sine, which is cosine. So you good with that? I just did product rule on the top. They took turns. The 11x went first, just 11. Sine just sat there. Then the 11x just sat there. Derivative of sine is cosine. They take turns. On the bottom, how do you do the derivative of the bottom? The 9 just goes to 0. Whoops, I'm on the wrong. Oh, there we go. And the other one, derivative of minus 9 cosine. Well, derivative of cosine is negative sine. So it's going to be negative 9 sine x, right? Because the derivative of cosine is negative sine. So here, if that's confusing, you could say, look, it's negative, gotta be in there, negative 9 times negative sine x. How about that? Same thing. It's getting a net positive on the bottom, isn't it? All right. Let's plug in our 0 again, though. Let's just plug in our 0. Plug in 0 here, 0 here, 0 here, 0 here. What are we going to get? 11 times sine of 0 is 0, plus 11 times 0, cosine of 0 is 1, over, let's be positive 9 sine of 0. That's a 0 down there. So what is that? That's 0 over 0. Again, so what does that mean? Do L'Hopital's a second time. Sometimes we need to do L'Hopital's twice. And you can do it again if you get 0 over 0. Right? So, oops, I'm not spelling it right. L'Hopital again. So I'm going to do, okay, limit. That's what's special about this. We go to L'Hopital's twice. So I'm going to do the derivative of the top only, separately, right? What's your 11 sine x? Well, this is not product rule because 11 doesn't have an x. It's just 11. So it's just 11 is just sitting there. Let me put in bar here. And derivative sine is cosine plus. Now, what about the derivative of this part? That's product rule. This part's product rule, right? Because this has an x, and so does this. So derivative of the first part, derivative of 11x is 11, times the second function unchanged, plus the first function unchanged, 11x times the derivative of the second derivative cosine is negative sine x. All right. Now for the bottom. The bottom is down here. It's going to be plus 9, right? Two negatives, positive 9. Derivative of sine is cosine. Okay. What's up with this? Well, let's plug in our 0 again. Plug in 0, plug in 0, plug in 0, plug in 0, plug in 0. What do you get? Cosine of 0 is 1, right? This right here is 1. This right here is 1. So it's 11 times 1, 11 times 1. In fact, I don't know if I have enough room. Let me bring it down. It's It's 11 times 1 plus 11 times 1 and plus 11 times 0 times 0. So that's gone over. Plug in a 0 there. So 9 cosine of 0 is 1. So what do we get? 11 plus 11 over 9, 22 over 9. There we go. We got the answer. We just had to do L'Hopital's twice.